Hello, we are Valeria, Santiago, Mariana, Diego, and Jair, students of architecture and civil engineering. And today we present our project, the Chessboard Pavilion, developed for the course Materials and Construction Procedures. The guiding concept comes from a chessboard, an idea that allowed us to work in order, repetition, and modularity. This concept emerged after revising our initial idea, because we realized we needed something not only aesthetic, but also constructive, capable of becoming a real structure supported by our formwork. We located the pavilion on an open site behind the university's pool. All this with an 80 centimeter slope, natural lighting, ventilation, and enough space to develop an ephemeral structure. From the beginning, this project was not only about designing a volume, but about understanding how architecture and engineering meet with the construction process. Before defining the final design, we analyzed several case studies that guide us with our decisions. The Serpentine Pavilion taught us the importance of structural lightness. Dynamic experimental pavilions help us understand exposed joints and how materials behave in assembly. And at last, the Lina Gotham's table pavilion inspires with its patterns, shadows, and permeability. These references were essential to translate our chessboard concept into a modular system. They help us understand why a clear grid was necessary, how the armatures should work, and how stability is achieved through bracing. Each case contributed a structural principle that we applied to our project. One of the most important parts of the project was learning how to build the formwork, and this is where we faced our first mistakes. At the beginning, the wooden timbers, braces, and beams we used were out of scale, too thick and heavy. So this forced us to rework everything, because the model wasn't accurately representing how the structure will behave in reality. We corrected the entire scale and adapted each element so it will make sense into a real formwork system. We used balsa wood to simulate the wooden timbers, beams, and horizontal supports. And we also used thin craft paper to represent the plywood. All materials were used as a simulation to get as close as possible to how the real construction system would look. During this process, we learned that it's not about placing pieces randomly. We had to understand what each element is, what it does, and how it works. For example, bracing prevents structural failure and the beam distributes loads. Also, the horizontal support stabilizes and the plywood acts as the formwork surface. Once we understood the role of each component, finally, the model made structural sense. Correcting the scale, changing materials, and rebuilding the formwork taught us to work with precision and to make decisions based on how a real structure functions. This was where we learned the most, because we had to transform theory into a physical construction, even within a model. For the electrical system, we incorporated all the conduit using green PVC conduit, organizing the roads so they will not interfere with columns or armatures. We also planned the location of light switches, placing them near access points to ensure practical and logical control of the lighting. For the hydraulic system, we integrated rainwater downspouts connected to the main drainage system, as well as the water line from the kitchenette directed to its corresponding discharge route. This allowed us to understand how service coexists within a modular project. For the walls, we used dense glass, only in areas requiring higher moisture resistance, especially near the kitchenette. On the roof, we work with three-dimensional armatures, modified into triangular shapes to provide more amplitude and visual lightness. We also developed the staircase with its raising and handrail, giving stability and continuity to the axis. The final model helped us to verify proportions, installation routes, and how every construction decision, from a panel to a pipe, affects the pavilion's stability and function. This project helped us grow because it confronted us with real design and construction errors. One of the most important lessons was the need to always verify scales. Our formwork was initially out of proportion, and we had to correct the wooden timbers, beams, and braces so the model would work like a real system. We also learned not to rely on the first idea, since our original concept wasn't structurally viable. We reorganized it and turned the chessboard into a modular system that could actually stand. Another major improvement was researching each construction element in depth. Understanding the role of bracing beams, panels, or armatures completely changes the way we build the model. Using simulation materials like balsa and craft paper also taught us how to represent real construction logic. Overall, this process made us more careful, more technical, and more aware of how architecture and engineering come together. It taught us to confirm scales, research materials, review installations early, and not to be afraid to correct mistakes. We are very sure these lessons will guide us in future projects.